got a hairstyle. See?
Hello, Mr. Eric, Mr. Rana, right?
It's hot.
Yeah. We know each integer, we can convert it to binary. For example, 17 in binary is 10001. 2 in binary is 10, okay? 14 in binary is... Anybody?
14 in binary is 1.
What's 15 in binary?
1. It is 0, 1, 1, 1.
Okay.
0, 1, 1, 0. 1, 1, 0.
Okay.
Yes.
Okay.
That's like a baby.
Another one which is 128, which is
1, 0.
how many 0?
0, 0.
How many 0? 2 to the power of
4.
2 to the power of 7. So 1, 2, 3, 4, 5, 6, 7. 127 is 0, 1, 1, 1, 1, 1, 1, 1, right?
You don't need 0.
Yeah. If you want to check if the integer n is a power of 2, we can do this n to the end. Okay, and the operation n minus 1. Okay, n bigger than 0 and this, right? Because if it's a power of 2, minus 1, subtract 1, it will be 0 followed by all 1s. And if we do the end, 0 and 1 is 0, all zeros. Make sense? Okay, because in binary, a power of 2 is 1 followed by some zeros. Make sense? Okay, so coming back to today's question, okay, this is a little bit knowledge about binary. So we want to count the number of the ones in the even and odd index. So the least significant bit, the rightmost one, is 0 index. Index 0. 0 index 0s. This one is 0 index 0. This one is index 1, etc. Okay. So here we have 1 on 0 and 4. So that's even index. So we need to return 2, and the second value is 0 because there's none ones on the odd index. Let's take a look at this example. Right? This is 0 index. This is 1 index. So there is only, okay, so this is not 0, this is 1. Even index, which is 0, we got no ones. On index 1, which is odd index, we have 1, 1, so 0, 1. Okay, makes sense. So we just basically want to count the number of ones. We want to count the ones, right? The number of ones
2.
in odd or even index, okay? For example, this one. This is 0, 1, 2, 3. How many ones on even index?
2.
This one and this one. So that's 1, okay? Because there's only one. How many ones are on odd index? These 2.
3.
2. Why is it 2? Why is it 3?
You can't blame him when you don't explain well.
Okay, so can you okay, so do you understand what I'm saying?
Oh yeah, that's 3.
Okay, so can you explain to Ryan?
So what? I know.
Okay, so you know now, right?
Okay. Of course I do. So what you're saying is, so you have indexes from the furthest to right, starts on 0 and then it increases when you go to the left, and as you can see, 0, 1, 2, 3, 4, and you're saying that on the even indexes, like 0, 2, 4, yeah, the even indexes, the number is even, and then you want to count how many ones are on the even indexes, and you're also counting how many ones are on the odd indexes, and you're showing this 2 numbers in the square brackets, and the first number is with even numbers, the other one is with odd numbers.
Perfect. Yes. Okay. So brilliant. That's exactly it. Okay. So now, how do we solve it?
We use a computer, obviously.
Okay. So how do we solve this problem? This kind of problem. Okay. So if I tell you, I want to do this same thing on number 9. Okay. So what are these 2 numbers? Number 9. How do we do it?
Turn into binary.
Turn into binary. Okay. What's the binary for this?
1001.
1001. Okay, so it's a plus 1. That's right. So 1001. So this is index 0, 1, 2, 3. So the number is
1, 1. 1, 1.
1, 1. Yes.
One.
Easy, yeah, seems easy question, eh? So how do we convert it to
Can I ask
binary? Later, how do we convert to binary? We talk about these many ways, right? So one of it is that divided by 2, right? 9 divided by 2 equals 4, remaining 1. 4 divided by 2 equals 2, remaining 0. 2 divided by 2 equals 1, remaining 0. 1 divided by 2 equals 0, remaining 1. Okay, 1, this is 0, we stop. And the binary is this way, 1, 0, 0, 1. So by looking this number 9, right? Because 9 in binary is this one. Every time we can check the least significant bit. And after we check it, we remove it. We can shift 1 position to the right? 9, shift 1 position to the right means that I remove this one. Shift it 1. And now we check this bit, and then we discard it. And we check this bit, and we remove this. Okay? Until we get a 0. So we can do this simple. Let's write the code. Define count bits. We're given this integer n, and we want to return this, right? You will return the list of integer. Okay, so the answer, because we're only returning 2 numbers, right? So the square bracket, which is the list, answer 0, 0. Okay? So at the beginning is number 0, right? So I equals 0 because it starts with the 0 index. So this is the index value. So while n, while we haven't reached the number 0, then answer I, right? Answer I is the even, right? Even. The first integer is the even. So answer I equals plus equals n and 1, right? Look, any number and 1 is, what's this meaning? Any number and 1 is the least significant bit. Okay, so for example, 9 is 1001. 9 and 1 is basically this one because and 1 is 0000001, right? And I only want to keep the least significant bit, so which is the rightmost bit. So if it's 1, then we increment the counter in the first counter, which is even. And then we want to remove it. Once we count it, right, we want to remove it. So n, shift 1 position to the right. So we remove this one, right? If this is 0, if the least significant bit is 0, if it's an even number, right? If this is the even number, n and 1 is 0. So answer I plus equals 0. It doesn't change the value, right? A counter is incremented by 0 means that we don't change it, right? Okay, so now this I, right? This I is index 0. Now the next one should be 1, right? This index 0, right? So now we are counting the even number. So the next bit should be odd number, right? So even number, odd number, and then next one is even number, and the next one is odd, even odd. Okay, so now I at the beginning is 0. Now should be changed to 1, and then should be changed to 0, should be changed to 1. So 0, 1, 0, 1, 0, 1. So if I is 0, so how should I change it to even number, change it to odd number? How do we cycle this? 0, I want to change it to 1. Okay, this is I equals 0, right? Next one should be 1. The next one should be 0. The next one should be 1. The next one should be 0. Okay.
So you plus 1 and then you subtract 1.
So now I is 0. So what should I do with the I?
1.
1. I is 0. And then how do I change it to 1?
E plus 1.
I equals I plus 1. Then that would be, and then the next one would be 2. And I want to get to
I'm saying that 0 plus 1 and then subtract 1.
Okay, so how can I write it here? I is 0. Now I want to change it to 1, and then I want to change it to 0. I want to change to 1, 0, 1, 0. It's a sequence. It's a cycle. And we can use the cycle. We talk about this, right? Cycle is the iterator. But it's simpler, the mathematics.
I equals 0, I equals 1, I equals 0, I equals 1.
Yeah. Okay, so how can we do this?
You just put it down.
Put it down. Yeah, we can use the if, right? If I equals 0, then I should be 1, right? So you can say I equals 0 if I is 1. Else should be 0, right? But there's other ways to do it. Simple math. Okay, so I equals something minus I. Okay, can you feel this value? I equals something minus I. What's this value? 1, yeah. Okay, I equals 1 minus I. Okay, Now I is 0, so 1 minus 0 is 1, right? Now if I is 1, it should be 0. It will become 0, right? If it is 0, it becomes 1. If it's 1, it becomes 0. That's what I meant. Well, I equals 1 minus I. So you make the I 0, 1, 0, 1, 0, and ongoing. Okay, so this is the loop. Yeah, cycle. I always use the cycle. All this one is also okay, right? I equals 0 if I equals 1, else equals 0. So or you can write it more straightforward. If I equals 0, then I equals 1, else I equals 0. Okay? Let's try an example and then that's it. Okay, so let's try the number 11. The 11 in binary is
Nice.
1.
Circle line, circle.
11 is a plus 2 plus 1, right? Or power of 2. So
1,
it's
1, 0, 1.
1,
No, 1, 0,
0,
1.
1, 0, 1, 1, right? This is 8.
Circle
This
line.
is 2. This is 1. Okay?
1, 2.
Okay, so now I have this answer. Answer equals.
1, 2, 1,
Okay, wait. Okay? So now this bit, I equals 0, okay?
1, 2, 1, 2.
So this one is 1, right? So I should increment here, plus 1 here, right? And I get rid of it. Actually, 0, so it should be plus 1 here, okay? This is I equals 0. Now it changes to 1.
Circle line,
Now
circle.
this is 1, right? So I should plus this here, right?
This is I.
And I get rid of it. And then now becomes 0 again. So now this is 0, right? So I should plus 0 here, plus 0. Get rid of it. And then now this should be 1, right? This is 1. Now plus 1 here. Okay? So look, this is the number. So we plus 1 here, plus 0 here, so it's 1. We plus 1 here, plus 1 here, so it's 2. So the answer is 1, 2. Am I right? Is it 1, 2?
Yes.
This is 0.
1, 2, 1, 2.
1, 2, 3. So it's
1, 2, 1, 2.
1
2.
and then 2. Yeah, okay? Yeah, makes sense. The time complexity for this one is log
I is
n.
1, I is 2. I.
Log n, because n is an integer, log n. They are log n bit.
Log in.
Okay? For example, like 15, how many bits? 15 is 1111, is 4 bits, right? So it's log to 15. Roughly is 4, right? It's actually less than 4. Log to 16 is 4, right? 2 to the power of 4 equals 16. We talk about this log function, right?
I
Okay?
is 1.
Okay, look at log function. Log A B equals C. Log base A B. Log A base A B. Okay, so what does this mean? Where can we get? Is A to the power of C equals B. Okay, simple as that. Look, A to the power of C equals B. So log A B equals C. Okay, makes sense, Eric? Yeah? Okay, so this time complexity is log 2n. Okay, space complexity is O1, right? We only use 2, O1. Okay, what have you learned today?
Binary.
Circle line, circle.
A number in binary.
Yeah, we have number. We have integer, yes.
And we want to label each number 0, 1, blah blah. How much digits it is. And we need to write the one how much ones are from even and how much are for odd. In a list.
In the list, it's just 2 numbers, right? 2 counters.
We have a problem.
We have a problem. Yes, we have a problem. Okay, so can you please?
Okay,
We can work it out.
so we'll be given a number in binary of that number. We label the numbers from right to left.
Can I have ice cream? I'm hot.
Okay, later.
In a number starting from 0 consecutively go up, and so the target is to find how much ones are in the even numbers, even indexes, and how much ones are in the odd indexes. And the answer is 0, 2 numbers, and in the square brackets. We're looking at a number, and then when we convert it into binary, yeah, and then you label them.
Yeah, actually, we're not converting to binary all one go. We're just looking at the least significant bit once at a time, right? We look at the one on the least significant bit, and then once we look at it, we just remove it by shifting position to the. Am I right? Does it make sense?
So it's basically converting into binary.
Yeah, in the reverse order, right? In the reverse order. Okay, that's it for today. Bye bye. Bye. Picture time.